Welcome, everybody. And just as you're joining in, I can see you joining in. You're coming to take part in the conversation of why is everybody talking about hydrogen and where does it fit into a net zero future? We've got three different voices to start the conversation off. We've got Nick Stapley, Daniel Musenga Grant, and Gary H. And what I'm just going to do is I'm just going to let each and one of you unmute yourselves, introduce yourselves, and give your, I suppose, an initial sentence of, well, why are you talking about hydrogen from your perspective? And then we can kind of move into the discussion and the conversation. It is a flexible conversation, so if you've got any questions at any point, Sahar, Jimmy, post them in the chat, raise your hand, join in the conversation. Okay, Daniel.
Okay, yeah, my name is Daniel Musenga Grant, and I am the environmental lead at HVS, or HV Systems. We're a company based in Scotland, and we're designing and developing hydrogen electric commercial vehicles, so vans and trucks powered by hydrogen. I've worked there for 4 years, so I've been 4 years in the hydrogen economy, and it's really starting to see a shift in the last 12 months towards societal acceptance of hydrogen. So that's why I'm here and what I can talk about.
Ooh, interesting, a shift in societal acceptance. Brilliant. Nick.
Thanks. Yeah. Hi, everyone. I'm Nick. I work for Logan Energy. I'm business development manager here. I have been for the last 4 years. Logan Energy's been in and around hydrogen and fuel cells for the last 25 years. We've seen it grow from a very small kind of niche cottage industry to one that's really kind of, I guess, benefiting from a lot of momentum and support from governments, from policymakers, from companies looking to find their place in the hydrogen industry, but also invest and support the hydrogen industry as well. We do everything from designing and manufacturing hydrogen refueling stations, production systems, fuel cell systems, whether that's a stationary or on-board vehicle. It's a pleasure to be here, and hopefully there'll be some questions.
Thanks, Nick. Gary.
So I was in the oil and gas industry, specifically the subsea industry, and during the lockdown I just thought, nah, I'm out of this, I want out. And I started looking at the environmental side of things. I've always been interested in it, but I looked at my previous career in the Royal Navy with the subsea engineering expertise that I've got, and thought, what could we do that could make things better? And hydrogen just seemed the best way to go for me. So yeah, so I started up my company from there.
Thanks, Gary. So I like this. So we're kind of like planting seeds of where we're going with the social acceptance, the increasing in investment, and it seemed like the most logical place for you to go, Gary. So the first question that I have for everybody is, well, why is hydrogen an attractive energy source on our journey to net zero? Because I'm assuming, you're saying, Daniel, there's more social acceptance, but for a lot of people who've heard hydrogen but don't know a lot about it, as I said, why is hydrogen an attractive energy source for our journey to net zero?
Yeah, hydrogen is great for lots of different reasons. We talk about the hydrogen economy. So it's covering not just transport, not just energy, not just heating, but all these different things. Hydrogen is the simplest element. It's just was the first one on the periodic table. But the gas that we're talking about today is H2. So two of those elements. In transport, you can take this H2 gas, put it through a fuel cell, and that will convert it into electricity and water. The water is the only emissions from a hydrogen vehicle, so it's zero emissions in terms of carbon emissions, and it can power a hydrogen vehicle by electricity. So that's in the vehicle sense. It enables you to have zero emission vehicles. When you get to the energy side of it, you can use it to produce electricity if you have the gas, or you can take excess renewable generation convert that to hydrogen and store it. So it's a good for an energy store as well. At the moment, you can put 20% hydrogen into our national gas grid, so gas for heating or cooking, and you wouldn't need to upgrade your boilers, you wouldn't need to upgrade your pipes up to 20% hydrogen. If you went to 100% hydrogen, you would have to upgrade the pipes and the boilers. So there's lots of different ways that hydrogen can be used, and if it's produced in a zero emissions way, then it doesn't produce emissions when it's used. So it's a real chance to take out a lot of petrol and diesel from our use in transport. It can replace some gas or all gas if we go that way in heating networks. And it can be great for energy storage as well, to enable us to fully utilize the renewable energy generation that we have.
Thanks very much, Daniel. Nick, do you want to build on that?
Yeah, absolutely. Yeah, I mean, everything Daniel says is entirely correct. One of the ways that we look at it is that hydrogen and green hydrogen, which is hydrogen made by electrolyzing water, so splitting water into hydrogen and oxygen and powering that with renewable electricity. It's pretty much the only one of the only ways of what we call sector shifting and sector coupling, and that's really kind of joining up the electricity market and our decarbonised electricity market with other sectors and other industries like transport, heat, industrial processes, chemicals, and that kind of thing. And it's a zero emission way of doing that, and it's a convenient way of doing it as well. If we can utilize electricity that would otherwise go to waste, for example, then we're increasing the efficiency across the whole sector. It's important to realize that hydrogen's not the only answer. We have to use it in conjunction with a lot of other things, but it's going to be a really big part of that answer. And it's one of the only ways that we can really get to net zero and beyond net zero as well, when we're thinking about how to decarbonize our whole energy use and supply, rather than just transport using batteries, for example.
Awesome, thank you, Nick. Anything you want to add on to that, Gary?
Just building on from that, so Michael Matheson, the Scottish Net Zero and Transition Secretary, he announced this morning the hydrogen action plan from the Scottish Government. So I kind of sped read a few pages of that earlier, and definitely the government sees it as quite a large part of the energy transition going forward. And then from the future, from 2045 onwards, as a source of power. So yeah, picking up on one of the things that Daniel said about the 20% in the network at the moment. So the Scottish Gas Network have been upgrading their pipelines, and I think it's 3 billion they've spent upgrading pipelines for specific town networks to take the 100% hydrogen that we would be looking for in the future. So there's definitely something that's in the pipeline. So, excuse the pun. So they have the H100 project in Methil and Fife, where they have an offshore wind turbine supplying an electrolyser with green power. The electrolyser is creating hydrogen, and then that's pumped into, I think it's 80 homes, where they've converted the boilers and the hobs to take 100% hydrogen. They've also put the same smell that you get in gas into the hydrogen, so the health and safety executive are happy with it, and that project's nearly finished at the moment. So that's a proof that it does actually work. So there's a lot of work going on out there, and the government's paper, there's loads of information in there and loads of projects that are already ongoing. And I guess it's just getting the awareness out into the whole of society and bringing everybody with us.
And I think what's been really interesting listening to all three of you talk as you've built upon each other is I'm hearing that where we're sitting at this precise moment is it's to do with vehicles and how do we make hydrogen vehicles, how do we store the energy, but the long-term potential of actually decarbonising the grid and what you had said there of, I think it was decoupling industry and transitioning industry, if I've got the words there correctly, Nick, and how the long-term thinking is already in place to start building the back end to make this transition. So it's almost like, what I'm hearing you say is hydrogen's here, hydrogen's coming, and we're actually planning quite deliberately to do this from the short-term perspective to the long-term perspective and make it integral to part of the net zero journey. So what I'd love to understand more with that is to go back to vehicles and understand more, especially Daniel, from you about how you're integrating it into vehicles, but also Nick, how you're managing with the energy storage of hydrogen as well, and then building upon that, and Gary, what you want to say there afterwards. So Daniel.
Yeah, I'll give you a wee look at our vehicles as well. If we were in person, I could hand these out, but that's our HGV truck and an MCV, which is kind of a large van, is what we're planning to do. And one thing that we're very, the reason that we're going for the large vehicles first is for a number of reasons. At the moment, the kind of the star of decarbonising transport is battery electric vehicles, and they're great for some applications, and we're definitely going to have battery electric vehicles with us from now on as we move into the transport future. But for larger vehicles, we're really struggling to get the battery vehicle technology to work at larger vehicle level. The battery starts to become so big that it eats into your payload, which is really important for commercial vehicles. So you have to almost choose between being able to carry as much on the back of your truck as you used to, or being able to go as far. And because it takes a lot, an hour, 2 hours, maybe up to 4 hours for a truck to recharge its battery, this isn't, it doesn't fit with the current operation that logistics sector needs. Because they need to be able to carry heavy loads, they need to be able to travel long distance, and they need to be able to refuel quickly. And at the moment, we can add zero emissions to that. They need to have zero emission vehicles. And hydrogen in the large vehicles is able to deliver all those needs. It only takes about 5 minutes to refuel a hydrogen truck. So it's the same model of refueling as we currently have with petrol and diesel, which will slot into the current logistics sector with minimal operational upheaval. And as we start to get the infrastructure out there, it will also mean that people can refuel their cars. So there's lots of hydrogen cars that you could buy right now, but where do you refuel them? So because we're going for the commercial vehicle sector, we're able to strategically implement a refueling network. So instead of having to replace all of our current petrol and diesel stations with hydrogen right now, if we start with the larger vehicles who often follow set routes, you can put one refueling station at your depot, one at your warehouse, and that'll cover the majority of your fleet needs. And as we get more and more companies to have these refueling stations between their own depot and warehouse, that will build up the network across the nation, and we'll be closer to getting to that hydrogen refueling station around each corner like we have our petrol and diesel now, which will enable more people like us who just need to drive, to work or to see someone in Edinburgh, that will enable more stations to be about people to refuel. So it's great to start in the commercial vehicles because the battery technology is not able to cover that. So we can bring the hydrogen in to meet a gap in the market, but it also starts to get the refueling infrastructure out there and starting to build up so that we're ready for moving more of our vehicles to hydrogen in the future when the refueling infrastructure is in place.
Awesome, thank you, Daniel. And it's interesting, I wasn't really aware that there was a lot of hydrogen cars already out there, so thanks for highlighting that. Nick, what about the challenges of batteries? Because I know that that's the area that you're specialising in.
Yeah, there's certainly on the hydrogen, challenges in the refueling side of things. I mean, what's really key is that demand of hydrogen drives the installation of infrastructure. So we have to work together with, providers of vehicles, those who are looking to operate hydrogen fleets, for example, and work with them to be able to provide hydrogen at the scale that they need it, and at a price that makes it economic. And the scale of demand is really important in that. So, you know, a lot of projects, when I started out at Logan Energy and when we really started focusing on hydrogen, a lot of projects were only kind of looking at 1 or 2 or 5 vehicles that needed refueling per day. And now we're looking at, for example, we're providing a refueling station for a fleet of 25 buses in Belfast. And that is already a significant enough demand for hydrogen that you can economically install a refueling infrastructure, install the hydrogen production that needs to go with that, and then also make it bigger so that other people can come and use it when it's not being used by the buses, and you can start decarbonising other sectors, and you can build on demand, and other vehicles can be available for other users. And it's important to think about it, you know, hydrogen can join the dots between, like Daniel said, the commercial sector, whether it's buses or ambulances or you know, vans, trucks, whatever, and then it can shift into the private user as well. Because we can't do all this on our own. We need to join together to do it, and offering hydrogen at a price equivalent to diesel can only really happen either through subsidies and government support, or by increasing the demand enough that it becomes economic. And it is challenging, you know, looking, there is actually coming to kind of, you know, where's hydrogen made from? Well, you know, where do you get it from? There's been a real challenge in actually securing hydrogen during the COP26 period. For those people who want to demonstrate their technology or run a bus on it or something like that. In Scotland, you can't go and just buy hydrogen, for example. It's very difficult to do that unless you go to the likes of, you know, BOC or Air Liquide or Air Products, but then they're going to charge you a fortune for it because you're asking for a spot price of hydrogen. So what demand drives the infrastructure on the refueling side, but it also drives the installation of the production as well. And that scale of demand decreases the price of hydrogen and makes it efficient and economic for other users.
If you live in Aberdeen, there are 2 hydrogen refueling stations, and I think are
well, one currently not working, so there's only one. But yeah.
And then Orkney as well. But yeah, you're right. There's very few places. I do know that there are solutions out there where both electrolyzers, so the things that produce hydrogen, green hydrogen, and the refueling infrastructure, both of these technologies are able to be put on the back of a truck now. So they've been able to fit all the technology into a container. So if you need to set up a hydrogen refueling station quickly, you can drop a container with an electrolyzer connected to the grid, and you can drop a hydrogen refueling station both off the back of a truck, and you can set up quite quickly now. But yeah, we're still not quite got the kind of set infrastructure in place in Scotland already.
Just leading on from that, so again, from the announcement of the Scottish Government this morning, they're looking at setting up regional hubs for hydrogen, and just a few figures. They've given 15 million to from the Energy Transition Fund to Aberdeen Council, so they can set it up, because Aberdeen have 3 different electrolyzers, and 2 of them I think they're not using yet because they're waiting on the demand coming up. But they have got a fleet of buses and cars in Aberdeen for the council. And just a little story, I know Gavin likes these stories. So I was having a coffee in Costa at Marischal Square, and I just wandered over to this car and thought, that's a hydrogen car. So I went over to the guy and said, how come you've got a hydrogen car? And he took his hat out and said, oh, I'm driving one of the dignitaries for the council for a meeting. And I said, oh, what's the range, you know, just so I could compare it. And he says, well, we've got 300 miles. He said, but it tells me the nearest fueling station's in Birmingham, which is 700 miles away. He said, but we've got the depot that we use for the buses. So, yeah, but the infrastructure there is planned again, by the government and business to put it in. So the regional hubs are going to be getting money to set up hubs in different regions within Scotland and refueling stations for transport as part of that plan. So, and very much focused on green hydrogen production as well. So they'll be linking it into wind farms and using surplus energy from wind powers. You know, like overnight the turbines are turning, everybody's in their bed, they're not using as much power. So they'll use that then to create hydrogen and store it.
Yeah. Do you think it might be helpful, Tabitha, if we went through the different types of hydrogen, because we're mentioning green hydrogen a lot?
Yeah, no, I think that would, because I know that there's a couple of questions there, you know, which in the early days, where will the fuel be, and will domestic vehicles have access to the fuel truck depots? And I think, Nick, you addressed that yes, you know, as demand increases, you'd be able to create the depots and then transport, or private individuals would come in. But I think it's even taken a step back, because you're talking about green hydrogen and the different types of hydrogen. And I just want to clarify to make sure that everybody understands in the most simplistic terms, and excuse me, because I'm going to break this down really simplistic. What you're saying is that if we, like in an ideal world, so give me a little bit of an imagine, you plug a machine into a power socket and you get electricity, right? And then you put water through it and something happens. And basically that separates the oxygen and the energy, and you've got actually hydrogen, and that's your fuel source.
Correct.
Perfect. So then what is the difference between green hydrogen and non-hydrogen and all the different forms of it?
Yeah, so there's currently 4 types of hydrogen that I'm aware of, and they've all got a colour. So there's grey hydrogen. Grey hydrogen is a byproduct of the fossil fuel industry. It's produced mostly at the moment by steam methane reforming, or SMR, and they did a life cycle analysis of it. You hear me well? It says my audio quality is low. You good? Yeah.
Yeah.
And they did a life cycle analysis of the grey hydrogen and found that for transport, it might actually be more polluting than petrol or diesel in the long run, just because it takes a lot of emissions to produce it. The next type of hydrogen, so that's grey. Grey is bad. We don't want grey hydrogen.
Grey, it's 9 to 1 as well. So 9 tons of carbon for 1 ton of hydrogen. I thought that was just phenomenal. And that's what's happening now and has been for a long time.
Yeah, so we definitely don't want to bake in grey hydrogen use to our future economy, because we'll be even more screwed than we are currently if we do that. The next type is blue hydrogen. Blue hydrogen is the same as grey, but has carbon capture storage technology attached to it. So instead of releasing those emissions, you capture them and try and store them underground. The problem with blue hydrogen is it's a potential for use, but there are leakages, and if that store leaks, then you're moving back towards being as bad as the grey hydrogen.
If I may just jump in, you can't go and buy blue hydrogen. Blue hydrogen doesn't exist. It is a plan to implement carbon capture and storage on existing grey hydrogen schemes or new grey hydrogen schemes. So if you go and buy hydrogen from the hydrogen gas company, for example, it's very likely that is grey hydrogen, as even they don't have a load of electrolyzers out there making hydrogen from water in a more green way. So I just wanted to make that clear. Blue hydrogen is potentially something that might be available, and there's a lot of government funding that's been announced recently to support schemes in the Humber and in Liverpool. Unfortunately, Scotland missed out on the UK government funding up at Acorn in Aberdeenshire, but hopefully they will be able to get the funding as well to proceed with that project. Sorry, Daniel.
Oh no, that's a great input. The next one is gold hydrogen. So I've only heard about this in the last couple of months. This is a section of northern Spain that they've found some naturally occurring pockets of pure hydrogen within the Earth's crust. And you can mine that in the same way that we currently mine natural gas. This is still obviously a pilot project. They're just starting to drill it, I think, around now, this month or last month. We're not sure if this is something that is a phenomenon, and it's just in this part of Spain. We don't know if it's across the world. Before this, we thought that hydrogen did not occur in its natural pure form on Earth. So this is quite a new development. So it's very new. We can't rely on gold hydrogen yet. We don't know if this will be the only pocket. We don't know if it's economic to mine. And then that leaves us with the one remaining, which is green hydrogen, the one that we're all really pushing for use, the one that I know Glasgow City Council has said if it's not green hydrogen, we don't want it used in our city. Green hydrogen is hydrogen produced in a zero carbon way. So there's mostly through electrolysis, which is the splitting of water into hydrogen and oxygen using electricity. But there's some ways you could do it through anaerobic digestion, some other small ways, but mostly we're looking at electrolysis. And this green hydrogen would mean that once it's produced, wherever we use it, we can have zero emissions from producing the electricity, producing the energy, all the way through its use. It's like having renewables instead of a fossil fuel plant. It just takes all of those emissions away from everything you're doing.
Yeah, no, that's really helpful, and I appreciate all the add-ins. So we're staying away. So in any future conversations, ignore the grey, ignore the blue, go for the green. And I'm already sitting thinking in terms of the gold. I mean, you're talking about mining, so there's potential long-term impacts of what the mining could actually create without being awareness of it. So something that I'm really curious about then, when you're talking about the green hydrogen, it's got the zero carbon, you've got the electrolysis. You were also talking about how there's fuel depots, and you could have fuel depots, and then, you know, Nick, you were saying that you have to go and buy it, you can't store it. So I'm curious then of how easy is it to actually store hydrogen, so that by the time you get the infrastructure going, and, you know, you're going to take your car, I'm imagining sometime in whatever future it is, you've got your hydrogen car, your buses and whatever else, you're having a hydrogen pump. I mean, is it the same kind of thing as what we'd be expecting, you know, like just looking exactly the same, feeling exactly the same as if you're putting it into your car? How well does hydrogen store?
Yeah, I mean, hydrogen stores, you know, you could store it in a cylinder as a compressed gas pretty much for forever. It's not going to, you know, it's not going to change in any way. It's still going to be hydrogen. I guess at the moment, because hydrogen is not used in such a massive scale for transport, we store it as a compressed gas, and it's stored on the vehicles as a compressed gas. So the hydrogen refueling station is in essence a store of hydrogen and the compressor, and then a dispensing system, and it is like, you know, you go up to a petrol or a diesel pump, you connect your nozzle to the car, it creates a pressure seal between the dispenser, between the refueling station and the vehicle, and the refueling station fills your vehicle. And like Daniel said before, it's as quick as filling a petrol or a diesel car at the moment. Jimmy, no, the fuel cell is the thing that turns hydrogen into electricity. So you need to store hydrogen separately. That hydrogen is then put through a fuel cell on the vehicle. It mixes with air that you bring in with blowers and whatever, and it creates electricity and water. You obviously exhaust the water and you use the electricity to drive the vehicle. And so it's an electric vehicle in this type. You can also combust hydrogen if you want to, and you know, drive a vehicle by combusting it, but you're still then potentially making nitrous oxides as well. So yeah, there's other ways that people are looking at storing hydrogen. Liquid hydrogen could be one of the ways that we either store hydrogen on vehicle, and companies like Daimler are looking at that, or in the refueling station. But there are challenges again with storing liquid hydrogen. There's boil off, so you have to really keep the hydrogen cold, and that takes energy. So it has to be the right situation in order to make that economic. And then you can also store hydrogen in other forms, like ammonia potentially. So you could transport it as ammonia rather than as a compressed gas in something called liquid organic hydrogen compounds. Again, the ammonia or the liquid organic hydrogen compound will need some sort of treatment in order to get the hydrogen out of it. So again, that adds another kind of efficiency loss to the whole system. So there's still research and development going on in terms of, you know, potentially what our hydrogen future is going to look like. But at the moment, compressed hydrogen is really simple. You know, from our point of view, making a refueling station, it's well understood technology. It's not, you know, it's not new stuff. It's been around for decades. And we're just using it in a different way, and we're applying it in a different way. And to answer your question, Stuart, we're applying all of the safety factors that need to be applied to all of, you know, these infrastructure installations. There are, of course, risks with any fuel type. You know, petrol, diesel, hydrogen, each of them has their own risk. And actually, a refueling station is really safe because you will not dispense hydrogen unless there is that pressure seal between the refueling station and the vehicle, and hydrogen won't be released until that's made. So you can't just go around, you know, spraying hydrogen everywhere and creating a hazard like that. So
in a lot of ways, it's safer than petrol. Yeah.
And if hydrogen leaks, it's so light, it just goes straight up into our atmosphere. It doesn't pool on the ground like a liquid fuel does.
Inflammable puddles.
Exactly. So yes, of course there are risks, and you know, those risks are well understood. The planning authorities and the people that sign off all of our systems are well versed and well, you know, those risks are well understood.
And I think as well that just recounting stories that I've heard, whenever I mention hydrogen, everybody also always says the Hindenburg. And it's like, come on, guys, bring us forward a little bit. We're not as far back as that. But going back a little bit, you mentioned about the blue hydrogen, Tabby, just ignoring it. No, we can't ignore it because we need a transition. There has to be a transition, especially for industry. I mean, we've talked a lot about transport, and yeah, that's fair enough. But the industry, so steel manufacturer uses a lot of carbon because they need to heat that up really hot. So they're looking at using hydrogen as the fuel source for heating up the steel to the warmer temperatures. And that, if that comes from a renewable energy sources, green hydrogen, and it completely takes the carbon out of that industry, which is huge. So they're looking at that as well. There's lots of projects going on over the world for that. And blue hydrogen is a step towards the green hydrogen. So we will need to use it as long as it gets us away from the grey, as Daniel correctly says, is the worst, which is what we're using at the moment. But I'm just thinking for bringing society with us, I'm not thinking that everybody's going to have a hydrogen car, because battery technology is being improved as we speak. And there are some really innovative projects that have small, light batteries that can do the same as the larger batteries now. And it's just a case of bringing it onto the market. So I think battery cars, electric battery cars, will probably be the most. But as Daniel correctly says, for larger transportation, and there's also a train in Bo'ness. Bo'ness have a hydrogen train. So they got a decommissioned train and they changed it into hydrogen with hydrogen fuel cell on it, and they're testing that at the moment. So these are the larger projects that are probably going to be where the hydrogen is for transportation. I think the trucks that Daniel was talking about, larger vans, but I think cars are probably going to be, you know, electric vehicles for, you know, going forward. But industry, certainly the steel manufacturer all over the world, if they can use green hydrogen for their fuel source, then we're taking a lot of carbon out of the atmosphere there. Also, as well, just for
battery-led.
go on, Dan. Go on, Diane.
Yeah, I think I do agree with you. Battery electric vehicles they've got to the market. They're very useful for going between your house and work if you live close. If you've got a charging point at your house, they're amazing, and they fit for what we need. But I think eventually, like in our maybe 2040, 2050, we'll see kind of 25% battery electric vehicle, 75% hydrogen vehicle over the whole transport sector, with a bias towards battery electric vehicle at the smaller end and a bias towards hydrogen at the upper end. Going back to the risks, just on vehicles. Yeah, go ahead, Gary.
A little aside, that there's a project in Japan. So the company in Japan gave all their employees electric vehicles with two-way charging connectors in the vehicles. The company has solar panels on the roofs. The solar panels can charge the battery-powered vehicles up through the day, allowed enough energy for the employees to get home. And when they get home, they plug in and get free electricity from the government overnight because nobody's using it. And they then drive their vehicles in the morning to the factory. And because they've got two-way charging, the vehicles supply the power to the building at the same time as being charged by the solar panels on the roof of the building. So they're decoupled from the grid and it doesn't cost the company anything. And that the only outlay they've had is the capex for, however many electric vehicles they needed. Yeah. And that is a zero carbon, absolutely there. All the transportation for all those people and that company's running costs for all their computers and infrastructure.
Yeah, so vehicle to grid charging, V2G they call it. And I know that Toyota has looked into this. So Toyota Mirai is a hydrogen powered car. And they've put the same system in where you can take the electricity from the vehicle into the house or the grid as well. And they've actually put this in as a feature in an emergency situation where your house loses power. Plug your car in, it can produce electricity on board from the hydrogen and power your house. I think one more thing I want to say to Stuart's question about the safety for vehicles in particular. Any hydrogen vehicle needs a direct pipeline from where the hydrogen is stored to the highest point in the vehicle. So if there is a need to put the hydrogen out, it'll go straight to the top of the vehicle. And then as Nick said, it's really light, so it'll just dissipate into the atmosphere. And there's also standards coming in which say you can't have a hydrogen storage within 40 centimeters of the front of the vehicle and 20 centimeters of the edge of the vehicle, just to protect it from road traffic incidences. But the canisters that we store hydrogen in are incredibly strong. I watched a video of Toyota's hydrogen canister, and it took 250 caliber bullets hitting the same point to rupture it. So they're made with 3 layers that are incredibly strong. And as I said, in the event if it does rupture, there is this direct pipeline to the top of the vehicle to put it into the atmosphere instead of it having any chance of collecting somewhere.
So there's something that's kind of bubbling up a couple of times that you've said it going back throughout this entire conversation, which is hydrogen is one of the solutions. And then the example that you gave of the factory there, Gary, shows how it can be integrated in. You're also talking about water. Is like the byproduct. So where I'm curious is this something that's been looked into? If we're talking about one of the challenges that we're facing, in the world as well as we're towards 2030, is that we potentially have water crises and water shortages. Is this then part of the attraction for hydrogen as well, that it potentially can actually supply water and create water, so there could actually be multi-purposes to it? Or is that just sitting there bubbling away?
Yeah, absolutely. So at the moment, you can desalinate water in cheaper ways than turning it into hydrogen. And so taking seawater and turning it into fresh water you can drink. But if we're already producing all of this hydrogen and using it for vehicles, is more difficult because obviously it's a small amount of water carried around in a vehicle. But if it's a large stationary application, such as a fuel cell that's powering a whole building or a whole city, you can actually take the water that's produced. You could put seawater in, produce your hydrogen from seawater. If you put 50 liters of seawater in, at the end you get 50 liters of fresh water out. So you're absolutely right. It could be used once we've got up to scale it can be used for desalinating water and solving part of the water crisis we're going to face.
Okay.
You use water to make hydrogen, so it's a process that basically you turn water into hydrogen, and then you turn hydrogen back into water, and that process creates electricity, which you use. So it is it's a circle it's a water cycle. So yeah, there are ways potentially of using seawater instead of fresh water. Water's used in our fossil fuel industry. Let's not forget that masses of water is used in the refining process, for example. So again, if we're not using that water and wasting that water, because that just goes, it's wasted, and using it for hydrogen, then potentially we could be using less water than we do now in our new kind of energy processes. But of course, it's if you have a shortage of water, you could make hydrogen where you don't have a shortage of water and transport that hydrogen to where you need to use it. So there's ways around it. My CEO was in Australia a couple of years ago, and one of the big questions was, well, we're going through a shortage of water. So what are we, how are we going to make all this hydrogen and make use of this water when we don't have it? And it's like, well, make it, desalinate it, because that's what we should be doing anyway. No one should have a shortage of water, really. It's like fuel. No one should be in fuel poverty either. And these are separate issues to decarbonising. But we need to find a way of, making our energy future make sense for everybody, rather than, letting people be less rich in terms of water or fuel or whatever.
Yeah.
Sorry, that was a bit of a rambling comment, but I hope you got the...
Go on yourself, Nick. Just bringing it back a little bit to Scotland. I mean, we've got excess water in all our lochs and all the rest. However, the Scottish Government plan to be a net exporter of hydrogen by 2035. They really are keen to be producing so much hydrogen from our offshore wind farms and enough onshore to supply our own supplies, to be a net exporter to Northern Europe and beyond. So there's a real potential there for a lot. We have got plenty of water. We're resource rich in Scotland in that side.
Yeah, no, I appreciate both. Sorry, Daniel, I'm just appreciating all the different comments.
Yeah, I was just going to answer Jimmy's question in the chat. I'm seeing is the water being used in a closed system? For vehicles, no, because you're producing it, say, at a wind farm somewhere. The hydrogen's been taken to the refueling station, and then they're put into the vehicle, and the vehicle will dispel the water wherever it is along the road. So that's definitely not a closed system. For much larger applications, say if we in the future we're powering our entire cities by hydrogen fuel cells, then that could be a closed system, but it would take management at that level. For vehicle level, it is too small, and the hydrogen is being produced in a different place from where it's being used.
Yeah, brilliant. And then there's just another question that's come in from Nina here about the batteries for hydrogen vehicles. Are they sustainable, or are they comparable to the ones for e-vehicles with all the problems with lithium, for example?
Yep, they are the same ones. They are just smaller for hydrogen vehicles at the moment.
Yeah, and I think that's really important, Daniel. Sorry, it's a much smaller battery, so you're not going to have the same demand of lithium as you and other minerals as well as you would in a purely battery electric vehicle.
Yeah, and part of what we're doing at HV Systems is building flexibility into our design, so that in the future, if a battery we're a systems integrator, so we don't make our own battery, we don't make our own fuel cell. We get the most efficient components and integrate them together. So if in the future someone produces a battery that is not a lithium-ion battery and it works really well for a vehicle, we're building the flexibility into our vehicles to be able to change that quickly and stop using the lithium-ion batteries.
That's interesting. So what you're saying there is, because I mean, I know that some companies use the concept of planned obsolescence into the design, you know, let's build it so it breaks so we actually have more. But what I'm hearing you say is actually we're starting to design that completely differently, of how quickly can we keep on just adapting and evolving the technology to make it more and more and more sustainable as we go from where we are now to 2030, 2045.
Oh, absolutely. We're right at the, as I said, the societal acceptance of hydrogen started in the last 12 months. So we're right at the start of a technology boom for hydrogen. It's been growing since 1830 when William Grove invented it in Wales, you know, 180, 190 years ago. But in the last 20 years, we've had some increase in fuel cell technology, which enables us now to be able to bring those vehicles to the road. But we expect the same as we see in smartphones, in internet, in battery electric vehicles. Now that it's coming to the market, there's going to be a massive boost to the technology. And we're expecting to see fuel cells increase in efficiency, batteries to decrease in size over the next 10 years even. And we're planning for that in our vehicle design. And one of the really important things about lithium-ion batteries and even the platinum and other rare earth materials that are needed for these vehicles is that we need to manage our resource use a lot better. We need to have a circular economy where the materials that go into these things are able to be extracted once we're finished using them and used again. So instead of having to always go back to the earth and then take more out, we need to design in recycling. We need to design in reuse right from the start, so we don't get to this point where we've discarded things that are worth so much to us.
Yeah, truly sustainable. Yeah. It just adding on to that as well. So the Scottish Government announced this morning their hydrogen action plan. So it's just been released, and with that, there's 100 million worth of investment for the hydrogen industry, which at the moment is quite small, but they're looking to make it much, much bigger. So policy and regulation and all that is going to be at the forefront of that. So yeah, it's like you're saying, it started a while back, but now it's really picking up pace because it is a valuable asset in the energy transition, definitely. And for net zero, it makes the most sense.
I'm curious, how quickly does a technology boom accelerate? So exponential growth, and I'm curious because this is me just thinking aloud here. So how quickly do you see this transition happening then? I mean, what is, if we do a little bit of visioning, we've hit 2030, where are we then with hydrogen implemented in Scottish infrastructure?
So the action plan this morning has an aim that Scotland is going to create 15% of its energy demand with hydrogen by 2030. So that's the aim of the action plan, is to put everything in place, the investment up front, the policy, the strategy, those legislative mechanisms that we need in order to bring confidence to the industry. And that will mean, 5 gigawatts of electrolysis by 2030. That is a huge acceleration from where we are at the moment. I mean, if we, I'm going to be blunt about this, we probably have less than 10 megawatts of electrolysis. In fact, we definitely have less than 10 megawatts of electrolysis in Scotland at the moment. It's probably more like 2, something like that. So we need to get from 2 megawatts to 5 gigawatts in 8 years. That's a really, really interesting challenge for the supply chain, for investors, for skills, for technology, but certainly having those plans put in writing and the strategy and the policy to back it up will mean that it will help us get there. We still need a lot of things to go right. We still need people to make vehicles like Daniel's doing, and we still need people to, make hydrogen boilers like Baxi and other companies like that are doing. It is happening, and there's a lot of steps along the journey to make yet, but it's going to be a massive part of the way that we use and create energy.
I think there's two factors we need to look at for timeline. The first is what we need to do. So if we don't start turning the trend of emissions down by 2030, we've got 7 years before we overshoot the 1.5. If we don't start going down within 7 years, we can kiss 1.5 degrees goodbye. So I think we're probably going to miss it anyway. We'll see what happens in the next 2 days. But you need massive change over the next 7 years. So that's by 2030 is what we need to do. The other thing to look at is history. The only other example we have of a complete technology leap in the transport industry is at the start of the last century, the 1900s, where in 14 years we went from horses being everywhere to the last horse-drawn coach in London being retired. And it only took 14 years. So if you look at, take like Tesla's release of the Model S in 2012 as the starting point of the new transport revolution from internal combustion engines to electric vehicles, which includes battery electric vehicles and hydrogen electric vehicles, then we're only 3 years away from the end of that 14 years. Yes, we've got incumbent fossil fuel industry fighting against that. Yes, we've got the incumbent car manufacturers and engine builders fighting against that. So it might take a bit longer, but we're already well into that 14 years of the transition period.
Thanks, Daniel. Anything else that you want to add, Gary, there, just as we're wrapping up?
So there's one a bit of information that I heard from a financial analysis. Bloomberg NEF, they were saying that electrolyzer technology is quite an old technology that for one type, and then there's another type that's quite new, but they've built gigafactories in China, and they're still building gigafactories in China with the expectation that demand worldwide for hydrogen is going to increase. But it might be a case where we're flooded with electrolyzers from China before the demand becomes high enough for them to sell all their electrolyzers. So I'm planning on getting a few of those electrolyzers myself. So.
I think there's one question left, Tabitha. We'll just address quickly. It's Jimmy's question about cost. So yes, electric vehicles often cost more than petrol vehicles at the moment. Hydrogen vehicles, again, we're 10 years behind battery electric vehicles in terms of this technology boom I talk about. So they're even more expensive at the moment. As we move through that boom, the cost will come down. As we reach economies of scale in the production of components, the cost will come down. But one final point is the governments of the G20 countries have given £188 billion to fossil fuel projects in the last 3 years alone, almost £200 billion. If they gave that money to renewable generation projects, if they gave that money to producing green hydrogen, if they gave that money to zero emission vehicles, then the price would come down as well. So we need to stop funding fossil fuels. We need to give that money to the zero emission future.
Awesome. Thank you very much, Daniel, for answering that last question there. And we have reached the hour of the conversation. Daniel, Nick, Gary, thank you very much for joining us for what is an enlightening conversation and really helping more and more people understand and increase the social acceptance of hydrogen so that we can hopefully accelerate that transition. I'm really grateful for your time. I'm really grateful, Sarah, Stuart, Nina, Juliet, Jimmy, for all your questions as well, which have helped make this a really engaging session. And Sarah's come in there at the back end. Really interesting. Thank you. And I like it. Excellent. We'll include the press release there, Zahar, in the communications that we're doing as we're putting all this into the Sutra ecosystem so that we can continue people watching all of the replays, knowing that a lot of people are going to be coming in afterwards.